All right, next, trigonometric ratios in the unit circle. Currently, you are aware that trig, ratio, sine, cosine, and tangent have something to do with triangles. If you're a mainstream Year 10 math student, it's only got to do with right angles. You're an extension math student, so do you know that sine, cosine, they relate to other triangles as well? We did that in your exam. However, these trig ratios have really interesting and useful applications on the unit circle. Why does this work? Because the radius of the unit circle we just established was
360 degrees.
No. How long is the radius of the unit circle? 1. Why is 1 useful? Because it allows us to cancel things. We're going to focus on one section of the unit circle here, just in this sort of quadrant. You'll learn what a quadrant is later. Point P on the unit circle has the coordinates A and B. So how far to the right of the origin is point A? What letter represents that? It's on the x-axis, but if the coordinates are A and B, how far have I gone to the right? A. And how far up have I gone? B. Good. Okay. So just get that and keep that in your mind. The line OP is the radius, so how long would it be? This? It's 1. So the line OP, we know, is 1 long. If I draw a line vertically down from P, like this, how long is that going to be?
B.
B. That's going to be B long. So that line vertically from P downwards has the length B. What kind of angle is that going to form with the x-axis?
It's going to form a right angle.
Right angle. So form a 90-degree angle with the x-axis. And it's going to touch the x-axis. Well, let's call this point X here. It's going to touch the x-axis at X. How far? How far from the origin is it touching the x-axis away? There's a letter there. A. Good. So we have a freaking triangle. We have a right angle triangle here with a side A, with a side B, and the hypotenuse is how long? 1. Okay? Why is that useful for us on the unit circle? Why are we trying to chuck these triangles onto a circle or anything? Well, we have a right angle triangle here that's been formed, triangle OPX. Let us deem the angle formed between OP and OX as theta. So what's theta? It's this, yeah, which is what we established on the previous diagram. Will someone remind me? Soccer told. What's cos theta? Something over something.
The adjacent over the hypotenuse.
Yep, so you looked at car, adjacent over hypotenuse. In this little triangle that we just drew, so we established that this is A long, this is B long, and this is 1 long. What's the adjacent? What's the adjacent to the angle? A. What's the hypotenuse? 1. What's anything divided by 1?
Itself.
Good. So cos theta is equal to A. So therefore, can I establish that cos theta on the unit circle is which coordinate of the point P? The x coordinate or the y coordinate? Is it telling me how far across I went, or is it telling me how far up or down I went?
How far across?
Across. So it's telling me the x coordinate. For any point along here, cos theta is how far I need to go right or left on that side, but right here to reach that point. Let's do the same thing for sine. So is opposite over
Hypotenuse.
What's the opposite in this situation?
B.
Over
1.
the hypotenuse is 1. So what's sine theta?
B.
B. So on the unit circle, sine theta on the unit circle is telling you what? Is it telling you the x coordinate of the position of P, or is it telling you the y coordinate?
The Y.
The y. It's telling you how far you've gone up or down from the x-axis. Okay? I will give you time up because I have stuff on this board. I'll turn this around, and then after I finish the recording, I'll turn it back around because I need to go over to tan. so just bear with me. I need to finish off with tan. According to this, what is tan? Something over something else. What's that? Good. Op over adjacent, which was
B over A or
B
Y over X.
over A. Good. But what did we just say? What did we just say A was? Cos theta. What did we just say B was? Sine theta. Okay? So tan is equal to sine theta over cos theta. But it's all coming together. There's a reason why you do this in year 8 and year 9 maths. Do you remember what slope or gradient was? The rise over run? So tan theta, and what did we just establish here? Sine theta is B, which is the rise, how far I went up. And A is cos theta, which is how far I went across. Isn't that the same as rise over run? So tan theta is equal to sine theta over cos theta. And tan theta is therefore the slope of the line from the origin to any point P on the unit circle. So I can use sine theta to work out how far up or down I've gone. I can use cos theta to work out how far I've gone across. And tan theta is going to tell me, well, the rate of increase of this line as I go across to the right. Okay? So suddenly you've got your trigonometry in this circle. I'll finish that video there so that you can get the notes down that you like.